Hello viewers, welcome back to the Multimagics channel. Hope everyone are having a great time. So last week as a part of the product development, we have seen how to increase the playback of a video, explicitly video. It means if you want to increase the playback by a factor 2, you can do it. If you want to decrease it by a factor 2, you can do it. And if you want to increase it by a factor 1.7 by 1.25, whatever factor you want to increase the playback, whether you want to increase or decrease, we saw that how to do that using the set PTS filter. So this week we will be going through how to filter or how to speed the audio by twice. So as I mentioned, why I explicitly mentioned how you want to speed audio twice along with video. For other factors we are working on it because we have to enhance the algorithm. We are not using any inbuilt filters provided by the FFmpeg like a tempo. We are building our own algorithm for filtering the audio samples. So what kind of filtering you need to do if you want to double the audio, what kind of filtering you want to do if you want to slow the audio, all those things we are readying it. For now currently it is the algorithm is ready for if you want to how to handle the filter the audio samples if you want to speed the audio playback by a factor 2. So on that note, let's start this video. So the next thing in the video, it is about let's quickly recap what we have done in the earlier video. It's just you have two video frames. For example, that video frame timestamp is 1 and this packet timestamp is 2, which means for 1 second I am playing 2 frames. I mean in general you will be for a second will be playing 30 frames, accordingly timestamps will be there, but just for simplicity purpose we are just playing 2 frames for a second. Now what happens if you apply that video filter? So this is 0.5 times PTS, which means we are actually increasing the time presentation timestamp. Instead of presenting it at one particular point, you want to present it much earlier. So which means like for half a second we can see the 2 frames. So that will create an illusion like video is playing fast. Instead of playing those 30 seconds, that for example you have 30 frames for a second, you want to present those frames in 15 seconds. So you need to tweak the presentation timestamp. So for that we in FFmpeg we just use this set PTS equal to 0.5 star PTS, and from code point of view also you can see initially we are initializing the FFmpeg filter which does this all audio things. Let's see how this process frames, and there is an FFmpeg filter graph initialization. This is for video. So you can see I am passing the what should be the video height, video width, pixel format, time base, and I am creating a filter here, and I am creating one more filter for this sync. I mean these are the steps how do you configure the filter, and I am setting my inputs and outputs, and here I am setting my set PTS, and all this filter graph context is here. So that's how you set the filter. So once the filter is set, during transcoding of the video you can read it from the buffer sync. So for example, okay, during when I'm processing frames from the file, so I have initialized the filter graph for video. So now I start transcoding the video. Transcoding means here you need to tweak the timestamps. For that you need to read the frame, and once I got the raw frame, I'm telling that instead of sending this actual iframe to the encoder, which is the actual input frame, I am sending the filtered frame. So the filtered frame is nothing but this is I am getting from the buffer sync, which means our filter graph actually. So now once you got this, you need to adjust the PTS presentation timestamp of that particular packet or the frame because now it should be like it depends on the factor. So all those things you can get from this buffer sync time base. Okay, so now once this is done you will be getting the video. So just quickly run what will happen. I mean I put some breakpoints, you can see here. So this is the original frame and this is the actual frame. Initially yes, both the values are 0. So now if you keep doing, yeah, you can see here it's 1001 almost by 2. So now it's 2002 1001, and this is 3003 1501. So that's how you filter. I mean you adjust the PTS of the actual frame and the filtered frame. We are not doing any PTS adjustment here. manually, I mean explicitly. With the help of filter graph initialization we are doing. So that's how we did for video. So just want to recap what we have done for the video. So now let's see what exactly we need to do for audio. Interestingly, for some reason, there is a filter called similar to set PTS filter. There is a tempo filter is there in FFmpeg. So we tried using this using initializing this audio filter and then adjusting the samples, all those things we have done, but it looks like it's not sure. If you're explicitly doing only audio playback, and if you want to increase just the audio and you don't bother about the video, this filter is working good. But our actual aim is to ensure you double the speed of video and audio together. So in that case, the filter creation and the filter initialization, all those things, it's quite a complex, and it is not good that you create such a complex filters and you slow down the process. So instead of that, okay, let's try we create our own. So that is the first difficulty we faced. So okay, so in video we used set PTS filter, and in audio we can use a tempo filter. Okay, let's initialize them separately, and then okay, you just filter the frame of audio, like boom, straight away it works. But that's so because we don't have, we are just digging more into the audio things also. We are not much aware, like okay, this is not straightforward. Then we took the help from our mentor, and then we realized that okay, audio is not that straightforward. We need to do sample by sample. So what we did that so now we have here sample 1, audio frame 1, and we have audio frame 2. So let's say this frame contains 1024 samples and this frame contains 1024 samples. So now okay, my bad, this is not video filter, this is audio filter. Let me quickly change it, okay, or else okay, audio filter, there you go. Yeah, so again, so we have an audio frame 1, audio frame 2, each frame has 1024 audio samples, and similarly audio 3 and audio 4 also has 1024 samples each. And these are the timestamps. So here these timestamps are based on number of samples accumulated by the particular frame. So now the new audio frame will be like this. So if we have, so we are taking 512 samples from audio frame 1, and we are taking 512 samples from audio frame 2, and we are giving a new filtered audio called filtered audio frame 1, which is a combination of these two frames. So like this, we are how we are selecting the 512 samples from here is we are just picking the alternate samples, and same from the audio frame 2, we are picking the alternate samples from this frame, alternate samples from this frame. We are combining it together in a new frame called filtered audio frame 1. So this way, whatever this way we can achieve whatever. So it means we are filtering the audios. We are just removing some samples. Of course, some audio effect will be there in the output, but since we are doubling, that will be not a significant thing. But main thing is that there can be a lot of algorithms, like which sample select. Here I am just going, I will just select the alternate samples. What about if I want to select like a 10th frame or like that? So you can also do that actually. In the sense, what I meant is like yeah, so if you have some samples, so you can definitely, let's say instead of alternate frame samples, I can pick every third sample or fifth sample like that. Since this is increasing the audio by a factor 2, you can just simply select the alternate frames of the audio samples, and then you can just simply ignore the in between samples. So that way we can achieve the audio samples doubling. Okay, so now let's see what happens if we do that in a sequence. So let's say you have a video file and you are reading a video file. So in that MP4 file, you have video frames and you will be having audio frames. So now you have video frame 1, audio frame 1, 2, and video frame 2, audio frame 1, 2, and video frame 3. Example, this is the sequence. So now after applying our video filter and audio filter together, so this is the sequence what we'll be seeing. So we have video frame 1 and we have audio frame 1 and video frame 2 and filtered audio frame 2, and we have video frame 3. Of course, this video frame 3 is also a filtered video frame but with a different timestamps, and here we are telling okay, I am still giving you 102 for audio samples, but for me now, but these samples are different. Now it will be more next frame samples also will be here. So that's how you increase the audio and video playback speed by a factor 2 using FFmpeg AV set PTS video filter and our own product development audio filter. So now we will see the code, how we have designed that audio filter and what are the things that need to be taken care. So as I mentioned, yes, so for that, first before running I will change my application properties in the sense, okay, so now I said no audio 1. So now if I say PA1 means enable, give me the audio also. So now I'll just remove this breakpoint, and then yeah, what happens here is when you are processing the frames, so let's go back to this. So when you are processing the frames, as you know, like AV read frame, write frames, all those things, I'm not going through all those things. So when you are processing frames, yes, you just read from the file, and then from the file you will get video frame and then audio frame. So you transcode the video frame and you transcode the audio frame. So while transcoding the video frame, of course you will be applying the FFmpeg set PTS filter and all those things you will be doing. So now as a part of transcoding audio, the first thing I will as a part of transcoding audio, the first thing I will do is I will just simply first store all the audio frames. So for example, here I am telling store AV audio frame. So I will not do any transcoding because I need to read that from the buffer and then later I need to mix it. So for that reason, you know, in the last video also we have seen this particular code for store AV frame audio. So I have a frame, I'm allocating a memory and I'm copying all the input frame properties to this temporary frame, and I'm allocating a buffer for this frame, and then I am copying all the input frame properties, and I am also copying the data. So here I am copying both data and properties of the input frame, which is an audio frame, into a temporary frame, which is audio frame, new audio frame. Okay, so simply I am just storing all the audio frame details into a buffer called AV frame details. So after storing all the audio samples into the buffer, so the next step is before writing here, so as you see here, I am telling okay, now the entire file has been done, entire file has been read, and video frame is already encoded and but not written into the file, and the audio frames or the samples are just stored into the buffer. Now we need to filter the audio frames. So for that, first before I am just filtering whatever there in the audio buffer, I am filtering those frames. So in this I am reading the values from the buffer, and then as I mentioned we are focusing on alternate values. That's the reason I am keeping this speed this for loop by a value of 2, incrementing by the value of 2 every loop. So frame 1 details I am storing in separate frame, and frame 2 audio frame I am storing it in a separate frame. So this is like, if let's say this is a 0th frame and this is the first frame, and the next iteration I will pick second frame and third frame. So each iteration I will be picking two new frames subsequently. So now I am just getting these values of number of channels and samples. I created a new frame. This is a build, create new frame. It just creates frame with whatever things you passed here. Okay, now channels, samples, all those. It's just creating a new frame and I'm creating a buffer for it. So now this is the interesting thing. So I am creating a new data. Okay, and to this data, to this new frame data, I am populating this new frame data with the help of frame 1 data. So the first 512 samples, I am populating the frame 1 data, and for the next 512 samples I am populating the frame 2 data. Okay, so here in this new frame we have 1024 samples, and the first size is 1024. It means it can accumulate 1024 samples. First 512 frames I am filling from data frame 1 data, and the next 512 samples I am filling from the frame 2, and from the frame 1 I am picking alternatively, and from the frame 2 also I am picking alternatively for both the channels. Okay, so from frame 1 I took alternate 512 samples and populating it to the new frame, and the rest of the 512 samples I am picking it the alternate samples from the frame 2. So that's how I am filtering the audio samples. Filtering here means precisely we are ignoring the audio samples such that it will create an illusion of audio is doubling. Okay, so since it is a factor of 2, it is easy to skip the alternate frames. But if the same logic, if you want to skip the audio frames for like 1.5 or 1.75 or 4 times or like that, the same logic doesn't work. We need to generalize it more. So for that specific reason I mentioned in the beginning of the video, we could able to speed audio and video together for a factor 2. Okay, so now yes, now this new frame data I'm assigning, I'm just adjusting, I'm just redoing all these things just to ensure all the properties of the actual frame are here. And please remember, you need to ensure that the PTS and are no longer for, we need to double by, I'm using frame 1 as a reference. You can also use frame 2 as a reference, but for simplicity I'm using frame 1 as a reference, and I'm doubling the PTS and the DTS of the original frame, because we have cut down the samples. So we have cut down the samples and we're putting all these samples into one frame. Now we need to adjust the timestamps accordingly such that the synchronization of the video and audio doesn't disturb. Okay, so now what I'm doing is this new frames I am pushing it into another buffer called filtered audio buffer. Okay, so we have two buffers. One buffer is to store the actual audio frames, and we have one more buffer where we are storing the filtered frames. So now what we will do with these filtered frames? So as you know, so I said filter audio frames. So now this will populate all the data into the filtered audio, and after populating all the data, you just now simply iterate through the complete buffer and read the data from that buffer, and then allocate all the data to it, and then allocate the buffer, and then you copy the properties and you copy the data from the original frame. Original frame is nothing but the filtered audio buffer frame, and then now you start encoding. So this is nothing but you populated the buffer, you read from the buffer, and from after reading that particular data frame from each buffer, you just copy it here. We are copying all these things because you are using pointer types, so we don't want to copy pointers. We want to read what is inside that pointer. So in the buffer we are storing the pointers, we are not storing the entire data. So because the buffer type is pointer, so both these buffers, whatever I am mentioning, so we are not creating any new memories, we are just storing the pointers. So we don't want to copy the pointers, we want to copy the entire, we want to do a deep copy. For that purpose I'm just assigning this to again a temporary frame or called as original frame, and then I'm just doing whatever. Okay, get the buffer for this original frame, and from in the populate this original frame properties and populate the data. That way you are copying the actual data inside that filtered buffer, and then yeah, finally you are just encoding that filtered frame and you are just unreferencing it. So let's put a one particular breakpoint here and then see how the PTS and DTS are tweaking. So let's run once quickly. Okay, the application is launched. So initially this is all the video frames are transcoded. I mean the PTS and DTS are tweaked by the factor 2, and the audio frames we are storing it into the buffer. So once the all file is read, then we will filter the audio frames. Of course it's a bit time taking process, and in that down the line we will be putting the multi-threading for it. So now you can see here, so I have a frame 1 and this is 0, and frame 2 is 1024, and the new frame is PTS is the frame 1 PTS by 2 and the number of samples inside this. So you keep going here. So now frame 2 has frame 1, frame 2. Now I have next sample, I got next sample, I got next sample. So like that you are taking few samples from this frame and few samples from this frame and keeping allocating those to new frame, and the number of samples still the same, total number of samples of course. So now I'll just disable this breakpoint and then keep continuing, and this is my console. So now here audio and video are, so now it is done, the audio video is doubled. So now let's check what happened actually. So I'm going to, let me go to the downloads folder. Yeah, this is my downloads folder, and let me refresh once. Okay, this is my latest file. This is the Iron Man trailer where now both audio and video are doubled by a factor 2. Yeah, I hope you are audible this, but my bad if it is not. Yeah. Yeah, you can see both video and audio are doubled and the quality is also good. Yeah, so I could able to see that both video and audio are doubled. Yeah, and there is no sync issues also. It's good that actually.
Let's face it, this is not the worst thing you've done me doing. I'm just not the hero type, clearly.
Yeah, so that's why here we are. So this is how you are doubling the video along with audio. And just to quickly recap, for video we are just depending on the video filter, and for audio we are created our own audio filter which is currently working for factor 2, but down the line we'll improve the code and make it much more enhanced for all the factors, and in fact for the slowing down also. So hope everyone enjoyed this video. Keep watching our channel, and then in the next video I will come up with how to reverse a video along with audio. So you have seen in the last week we have reversed only video. Now video with audio, how do you reverse it? So once, then quickly we'll go to that video first and then come back for playback speed with the different factors. Okay, so hope everyone enjoyed the video. Take care, bye.